Okay, now we're going to learn how to put it all together, writing a balanced redox reaction given reactants and products. Now, keep in mind that last example we did, that's way messier than anything I would ask you to do without first telling you what the half reactions are. Okay, that was just to show you that they can be pretty involved, but we would never give that to you unless I had already said, you've got these two half reactions, balance it. Okay. So now let's look at what we have here. I've got an overall oxidation reduction reaction. The first thing I need to do is assign oxidation numbers. The first one's not too hard because they're all monatomic. I have a charge, an oxidation number of 0, +2, +3, and 0. Okay. Assign what's oxidized and what's reduced. We first want to decide what's being oxidized, what's being reduced. Well, aluminum went from 0 to +3. That became more positive. That's oxidation. So aluminum is oxidized. And then copper went from +2 to 0. It's reduced. All right, we want to break it in half. We want to break these down into oxidation reaction and a reduction reaction and balance them with the same number of elements first, and then check to see if the charge is balanced using electrons. So we want to balance it with using electrons. Starting out, let's split it in half. I'm going to put oxidation and then reduction. Okay, so oxidation, and then we're going to have reduction. Our oxidation half reaction is aluminum, and leave some space on the left and on the right so you can balance with electrons and such. Aluminum is just turning into Al3+. Well, it became more positive by 3, so that tells me I need 3 electrons on the right to balance it out. Now let's look at our copper. Got Cu2+ becoming just plain old copper. It looks like it's more negative by 2 as we go from left to right. So that means I need 2 more electrons on the reactant side. So I have 2 electrons, and I've got 3 electrons. Hopefully you can kind of see what to do here. I need to make that number the same. Okay, so balance the charges by adding electrons. That was step 5. Step 6, we want to multiply the half reactions to make the number the same, and then we're going to do what we did in the last step where we combine them together and cancel out everything that's the same on both sides. So I'm going to multiply 3 by 2, and I'm going to multiply 2 by 3. All right, that gives us our half reactions of 2 aluminum yields 2Al3+ plus 6 electrons. And we have 3 times 2, that gives us 6 electrons, 3 copper ions, and that gives us 3 copper. Okay, and then we just add these together. I've got 2Al plus 6 electrons plus 3 Cu2 plus yields 2Al3 plus 6 electrons plus 3 Cu. Now let's look at what we can get rid of. What can we cancel? I can cancel out my 6 electrons. The aluminum and the copper, they're both changing. I cannot eliminate either of those. So we're just going to add these together, or just rewrite it without our electrons. So 2Al plus 3 Cu2 plus yields 2Al3 plus 3 Cu. And that's our final answer. Last problem. You can pause it and try it yourself if you feel comfortable. K is by itself, it's 0. Br2, it's an element, it's just 0. Then I've got positive, that's +1, of course. And Br minus, that is -1. Okay, let's write oxidation and reduction. Oxidation half is going to be K, turning into K plus. It became more positive by 1, so I need 1 electron on the right to balance it out. Okay, now I've got bromine, Br2, turns into bromide. Be careful here. This is where you have to make sure that you check if everything's balanced. I have the same number of potassium on both sides, but bromine is not balanced. If you were just balancing this as a normal equation, you would see I have 2 bromine atoms on the left, and I've got only 1 bromine atom on the right, only 1 bromide ion actually. I need to balance out the bromine with 2 bromide ions. It changes things because now I have a -2 charge on the right, so I need 2 electrons on the left, not just 1. You can see that we need to multiply this by 2 to make our electrons the same. And then I'm just going to add these up in one step because this one looks fairly simple. I've got 2K plus 2 electrons plus Br2 yields 2K plus 2 electrons plus 2 Br minus. What can we cancel out? 2 electrons, 2 electrons, and then that looks like that's it, just 2K plus Br2 yields 2K plus 2 Br minus, and there you have it. You ought to be able to work through all of the practice now, assigning oxidation numbers, deciding whether oxidation or reduction is happening, balancing a redox reaction in several different formats. Let us know if you have any questions.